meaning of the fundamental theorem of calculus, which states that in order to calculate the antiderivative of a function f prime of t dt between a and b, that would equal f of b minus f of a. Meaning that anytime we have a continuous function f prime of t, to evaluate the integral, that the answer will be the antiderivative evaluated at the upper limit minus the antiderivative evaluated at the lower limit. It is also, this is the area under the curve of the function f prime. For example, if this, the curve of f prime, the integral a to b of f prime of t dt is the area calculated from a to b. So as an example, for example here, y prime, which is the derivative of y, is given as 2 plus 1 over x squared, and given y of 1 equals 6, which is the antiderivative of y prime, find y of 3. For that, we're going to apply the fundamental theorem of calculus. So I'm going to evaluate the integral from 1 to 3 of the derivative function 2 plus 1 over x squared dx. According to fundamental theorem of calculus, this is equal to f of 3 minus f of 1. Now remember, this integral I can calculate using my knowledge of the antiderivative. The antiderivative of 2 is 2x, and the antiderivative of 1 over x squared is negative 1 over x, and that is evaluated from 1 to 3. That should equal to f of 3 minus f of 1, that is given as 6. Or if you want, we called it f, but we could also call it y of 3 minus y of 1. Alright? Now, to evaluate this expression right here, I'm going to have to plug in 3 first. 2 times 3 is 6, minus 1 over 3, and that minus the expression when I replace x by 1, which is 2x, 2 times 1 is 2, minus 1. And if I bring the 6 to the other side, it will be 6 plus this expression is equal to f of 3. So after calculating the left side, this will give me f of 3. It would equal to 10 and 2/3, or 32 over 3. Example number 2, again, given is the f prime of x equals cosine of 2x, and f of 0 equals 3, we're asked to find f of pi over 4. Now remember, this is a classic fundamental theorem of calculus problem. Why? Because I'm asked to find the final position moving the function from 0 to pi over 4, given the initial position and given the derivative. So if I integrate the derivative function from 0 to pi over 4, that should give me f of pi over 4 minus f of 0. That's exactly applying the definition, of the fundamental theorem of calculus. Now, since f prime is cosine 2x, I'm going to replace f prime by the cosine of 2x. My limits are from 0 to pi over 4. And since f of 0 is given as 3, I'm going to replace that. So it'll be f of pi over 4 minus 3. Let's go ahead and extend our screen. There we go. The antiderivative of cosine of 2x is 1/2 sine of 2x from 0 to pi over 4. And this is a property, it's either I can use u substitution, replacing u by 2x and finding the integral, or I can just use the fact that cosine of ax dx is equal to 1 over a sine of ax plus c. Alright? This property right here. This is exactly what I used here. And this is going to give me my f of pi over 4 by sending 3 to the other side or adding 3 to both sides. F of pi over 4 will equal 3 plus the integral evaluated from 0 to pi over 4 of cosine of 2x, which now if we apply the limits, 3 plus 1/2. Since both terms will have 1/2, I can pull 1/2 out. And if I plug in pi over 4, 2 times pi over 4 will be pi over 2, and sine of pi over 2 is 1, minus, if I plug in 0, it would be just sine of 0, which is 0, and that should equal f of pi over 4. Now, 1 minus 0 is 1, times 1/2 is 1/2, and 3 plus 1/2 is 3, 3.5, or 7 over 2 is equal to f of pi over 4.